So let us, by using Vsepr now, let us use what? Vsepr theory. Let me keep it here. We are still on what? Say what? Valence shell, spar electron, pair repulsion theory. So that's where we are. So by using the Vsepr theory, let me go to determine geometry, geometry, and what? And shape of zero lone pair molecule. Zero what? Lone pair what? Molecule. So this is a molecule. This is a what? A molecule with no lone pair at central atom. At central, at what? Central and what? Atom. So now let us look at what? All the molecule that is have a AB2 formula. A molecule that is have AB2 what? Formula. The first one is A what? AB2 what? Formula. So we have a molecule, some molecule that have AB2 formulas. What are the molecule? We have what? Example of this molecule are such as what? As CO2 and BeCl2. So those are the two molecules that always been in what? AB formula. If you look at this AB now, here, two atoms are involved here. This one, this A, we call it what? Central atom. It should be at middle. This B, we call it what? Side what? Atom. It will be at the what? At the side. Let us look at the molecule now. And there is a theory behind what? AB2 molecule. All AB2 molecule have geometry of what? Of linear. They are what? Automatic geometry is what? Is linear. And their geometry is what? Is linear. And their angle is what? One what? 180. According to the first part. But any molecule that is geometry is linear, its angle will also what? One what? 180. So let us look at it now. If we have this AB, let us draw it. I said A will be at center. We have A at the center. We have B here. We have another B here. Have you now? So you can see that what they are on a straight what? Straight line. So the sum of angle on a straight line is what? They are on a straight what? Straight line. And the sum of angle on a straight line is equal to what? One what? 180. And here, this is what? A molecule with zero lone pair. The bond, we have just two bond pair. There is no lone pair. Abi, since this molecule has what? No what? Lone pair. but it has what? Two what? Bond pair. Abi? You can have what? What is the bond pair here? Bond pair is what? Is two. Out of lone pair. Lone pair is what? Is zero. There is no what? Lone pair. So any molecule that is have what? Bond pair, but no what? Zero lone pair. I said this from the rules. So that what? The geometry will always equal to the what? Shape. So what? Therefore, what? Geometry is equal to the shape. So what is geometry? Geometry is what? Geometry of this shape is what? Is linear, and shape is also what? Linear. And then what is angle there? Angle is what? 180 degree. So this is what? Is the same thing for what? For CO2 and what? BCl2. If you use CO2 now, we have it in this form, this. And there is a rule that says that what? For all, take what? CO2. No, CO2 is also what? This, abi? You can see it now. It's linear. And from the rules, say that what? Multiple angle we consider as what? Super single angle. So there are multiple angle here, but we see them as what? As a single angle. So it's a what? A straight what? Look like one what? 180 degree. Abi? And so the for this CO2 now, the we have how many bond pair? Two. It's not four because from the first pass through, for you to determine the shape, the double bond will appear as what? Single bond. That's the last rule under first part theory. So the shape here is what? The bond pair here. Bond pair here is what? Is two. You count these two double bond as one. That's also what? As one, according to the rules. So the lone pair is what? Zero. And what is the shape? Geometry Geometry and shape are equal. Geometry is what? Is linear. And what? Shape is also what? Linear. And angle is what? 180. You can also, the same thing for what? For this beryllium, which is what? Beryllium is BeCl, BeC what? Cl. So it also have a what? A straight, is linear 180. So the second one, let us look at for what? AB2 molecule. AB3 what? Molecule. For AB3 molecule, example of this, what we have BF3, we have what? B what? BF3. AB what? Molecule. A molecule without what? Lone pair. And here, don't forget that what? The AB, for every AB molecule, they have geometry. Let me use G, represent. Their geometry is what? Trigonal, planar. That is their what? Their geometry, and their angle is what? 120 degree, according to the what? To the first far. So, and here, you can see that this A is what? Central atom. This B is what? The B is what? Is side atom. So if we want to draw this now, we have something like this. This is what A as a central atom. We have B here. We have another one B here. We have another what B here. You can see that what this side is equal to this side. This side is equal to this side, like equilateral what triangle. So if you look at what the three angle to give out what 360. By dividing 360 into 2, we have what 120. So the angle here is what 1 what 120. The angle here is 120. The angle here is also what 120. So here now this molecule now it has what is bond pair? Bond pair here, how many bond? 1, 2, 3 is 3. What is lone pair? We have said it before that what? There is no what? Lone pair is 0. So when lone pair, a molecule that has 0 lone pair, what will happen there? We all agree that what? Geometry of that what? Shape, which is what? G, geometry equal to the what? To the shape. Geometry of that molecule was shape of the molecule. And then we are given that geometry is what? G is trigonal. Now what? Planar. The shape will also what? Trigonal, planar. What is angle? Is what? 120. So the next thing is what? Let us look at what? A molecule of AB3. And here, I said B what? BF3 is what? Is a case of what? Of study. If you draw the what? The molecule of BF3, it will give you something like this nature. The shape B, F, F, F. The angle here is what? 120, 120, 120. Have you now? So let us look at for the molecule of AB4 molecule. So AB4 molecule, example, we have such as methane, tetrachloromethane. And the geometry from Vsepr theory for this AB4 molecule, according to the what? Vsepr theory, that what? AB4 molecule, their geometry is tetrahedral. Tetra what? Hydra. And the angle is 109.5. So if you now draw the what? The angle, we have A like this, we have B here, we have another B, we have what? B, and we have what? B. So if you look at the shape, it's tetra what? Tetrahedral, and the angle is what? One. Sorry. The angle is what? 109.5 degree. Tetra what? Tetrahedral. And look at the shape now. What is the what? The bond pair here. The number of the bond pair, 1, 2, 3, 4. Bond pair is 2. Lone pair of electron is 0. Since is equal, geometry is equal to the what? To the shape. Abi, what is geometry is what? What? Tetrahedral. And the shape we also what? What? Tetrahedral. And angle is what? 109.5 degree. And a molecule which is represent this is methane. Is what? Methane. And the angle here is what? 1095. So if we look at it now, the bond pair is 0, 2. Lone pair is 0. Geometric, go to the shape. Geometric is what? Tetrahedral. Shape is also what? Tetrahedral. And the angle A is what? 1095. So the next one is what? Let us look at what? A molecule of AB5. AB5 such as what? PCl5. PCl5. And what is their geometry? According to the Vsepr theory, geometric for the what? AB, AB5 is what? Tetrahedral by pyramid or trigonal by pyramid, and the angle here, angle here is what? Is 90 degree, 120 watts degree, according to the what? Vsepr theory. It said for every AB5 molecule, the have trigonal by pyramid, and the angle is what? 90 and 120 degree. So let us look at what? The AB structure. We have A at the what? Center. We have B in this form. We have another B here. We have what? Another what? B here. We have another what? B. We have another what? B here. We have another what? B. It's 5 now. Sorry. It's okay. It's 5. Yes. This is the shape. And look at this thing. You will observe that what? This bond AB here is perpendicular with what? With this one. So you will now observe that what? The angle between these two is what? The angle here is right what? Right angle, which is 90 what? 90 degree. Abi? And the angle, look at this trigonal. This between B and this what? B is 120, which is written as what? And this one is what? 120 from here to here, or from here to here is what? 1 what? 120. But this side alone is 90 degree. That's why we have what? 90 and what? 120. And the shape is what? Trigonal by what? By pyramidal. Let us look at what? The bond pair. Bond pair there is what? How many bond pair? 5. lone pair is 0. When lone pair is equal to the 0, geometric equal to the what? Shape. Geometric is what? Triagonal by what? Pyramidal. And shape is also triagonal by pyramidal. Angle A is what? 90 degree and 120 degree. So that's for what? AB. The last molecule here is what? Molecule of AB6. Six what? What? Molecule. Example, e.g., we have SL6. We have sulfur chloride or sulfur chloride 6. An example. So automatically, what? Geometric for this base 6 is octahedral. And the what? The angle A is 90 what? 90 degree. So let us look at the what? The molecule. Now, we have what? A, B is here, another B is here, another B is here, another B is here, another B is what? Here, making 5. And we have another what? A, B is here, making what? 6. If you look at the what? The shape, it will give us what? What? Octahedral in what? Shape. And the angle here is what? Angle 90 degree. And this, for this, the number of what? Of bond pair is what? 6. Lone pair of electron 0. Geometry equal to the what? Shape. Geometry is octahedral. And the shape is also octahedral. Angle is what? 90 degree. And this is the same for what? If you draw a diagram of sulfur, chloride, 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 and this. So this is what? Same. So I'm done with what? The molecule, the shape, geometry, and the shape of a molecule without what? Lone pair. So the next one now is what? Geometry and the shape of what? A molecule with what? With lone pair. Yeah? To determine geometry and shape of what? Molecule with what? With lone pairs of electron. So this one is what? Another case entirely. For lone pair molecules, we have how many cases? 6. Let us look at what? A molecule with what? Without what? With lone pair. The first one, so we have AB2 E molecule. AB2E what? Molecule. Look at this. This A you have here is what? Central atom. This B is what? Site atom. It will be at the site. This E we have here is lone pair. This is what? Lone what? Lone pair. This is central atom. This B is site, abi? We tell you that what this B will attach to what? To A here, abi? This lone pair attached to what? To A here. So how many bonds now attached to what? To A? It should be 3, abi? From this diagram, we can have that what? Bond pair, which is this B, is what? Is 2. This E represents what? The E represents lone what? Lone pair. How many E do we have here? 1. One what? Lone pair. If you now add the 3 together, 1 plus 2 to give you what? 3 electron pair. 3 what? Electron what? Pair. Do you know what we now do now? This 3 electron pair is partially equivalent. Equivalent to what? This is 2, this one is 1, making it 3. So you can now imagine that what? You have a electron 3. That you have A base what? Base 3. Because we have one bond pair, 2 bond pair, 1 lone pair, add together, call it what? A3. So for every A3, what is geometry? Is what? Trigonal, planar, with angle what? 1, 3. So logically now, this molecule, logically, this molecule have what? Geometry of what? Geometry of what? Trigonal. That's what's supposed to have. Abi, an angle of what? 120. This is what it's supposed to have, oh, because it has what? For every molecule that have what? 3 electron pair, it's same thing as what? AB3. We have 1 bond pair plus 1 lone pair, give you a 3 electron pair. So add the 2 together and make it what? 3. Abi, let me now draw the structure of what? Of this AB what? AB. Yeah, look at it, the structure now. Can you should drop it here? Let me draw it. This place is not okay. Let me draw it here. Oh yeah, this structure will be in this form now. The structure will be in this form now. See it oh. We have A. This A bond with what? B. This is the bond between what? Let me use black marker. B. Bond with what? B. Abi. And look here. This E is what? This E is the lone pair. And this is the what? Lone what? Lone pair. You know, we have A, B, E. This is E. This is B. Abi. So check this site. What is angle here? 120, 120, 120. Abi. So this angle here You have between what? Let me draw this thing very well. The shape is not really encouraging. So, here we have 120 or Dabi. Good. This place too is supposed to what? We have repulsion here. Hi, let me use red marker. We have what? Repulsion here. This is what? We have repulsion here. We also have what? Another repulsion what? Here. We also have another repulsion what? Here. Back to the what? The second law of Vsepr theory that said what? Electron pair have different repulsion. Look at this now. Between this place, this is what? Bond, a lone pair, bond pair. Check the stuff. I gave you the diagram. I said what? And then I said, look at this. The second law. I said, if what should I call it? Oh? I said what? The lone pair is greater than what? Lone pair, bond pair. Greater than what? Bond pair, bond pair. We apply it here now. So between these two repulsion, what do we have here? So here, this place is what? Lone pair. This one is what? Bond pair. Here we have what? Lone pair, bond pair. Here we also have what? Lone pair, bond pair. The repulsion we have here. But here, we have what? Lone what? We have bond pair, bond pair. Abi? Good. But from this now, which of the three we have what? You can see that what? Lone pair, bond pair. This one, this one is greater than what? Than this. Abi? This one greater than this. No, greater than this. And a lot of that. This bond pair, lone pair, we compress. What? We compress what? This angle we have here. If they compress the angle we have here, our bond, it will now be what? Shift like this. It will be what? Shift like this. You now have what? B. You have what? B. Abi, when it shifts, instead of what? Of adding what? Angle one what? 120 there. This thing is now be what? It will be reduced to what? It will be reduced to what? To angle 109 or less than 120. But now have what? 109 angle here. Oh, hope you are getting it now. And I said it before that the what determines the bond of a molecule or the angle of a molecule can be determined by what? By bond pair. See now, this is the bond. These two bonds here determine the what? The angle. Or in normal ground, this is triagonal. Abi, this is what? What? Triagonal. But when the what? This thing happen to it, lone pair, bond pair, lone pair, pair. The repulsion will happen here. This bond will now compress. When it is compressed, the angle you have, which is what? 120, will be what? Will be reduced. So as a result of that, what is our conclusion now? Here, the bond what? Bond pair is equal to what? How many? 2. Out of lone pair. Lone pair is what? Is 1. So when is lone pair is 1? Geometry is not equal to the what? Shape. What is geometry? Our geometry is what? What's our geometry? Our geometry is what? Try what? Triangle. Now, Abi? So the shape here now is not what triangle now. The shape we call it what V or bent shape. We call it what bent what shape because it's what is bent. So and here what is the shape? It's still triangle now. So what make the what the shape of this one is not be equal to triangle now? Equal to the what? To the geometry because of the presence of lone pair here. So and the angle here is what? Is 120. The angle here will be what? 109 degree. Abi? And then what molecule that we can use to what? To represent this? Yes, example of the molecule that have be this, Abi? Let me say e.g. example of molecule here, e.g. we have ozone. We have what? Ozone. If you look at what ozone have what? Three oxygen. Let me draw it here. Ozone is this. This side is double bond. This side is single bond. Yes, this side is what? Is double. This side is what? Is single what? Bond. And I said this single bond is not in this first part theory, you will see it as what? Single what? Single bond. And at this particular place here, we have what? Uh, bond lone pair. So you can now see that what? This ozone now, the repulsion we have is supposed to have 120 degree here. So the repulsion here between this lone pair and the bond pair and the pair between what? Lone pair here and this what? They will now bend. If they bend now, the what? The angle of this side will be what? Will be reduced. This thing will now shift inside, and the angle from there, it will now be what? One less than 120. Call it what? 109 degree. And the second one, this is first, Abi. The second one is what? A molecule of AB3E. For a molecule of AB3, e.g., we have ammonia, Na3. So here, this is central atom, this is what side atom, this is what lone pair. So we have what? What is the number of bond pair we have here? The bond pair here now is what? B pair is what? Is 3. Out of lone pair is 1. Automatically, we have 3 what? 3 electron pair. This 3 electron pair, it will tell you that what? Logically, that this molecule will be what? This is 3. You have 4. Sorry. If you add 3 plus 4, 1 to give us 4. 4. So it will tell you that automatically that what? We have what? AE4. Abi, for every molecule that is have what? AE4, what is what? Geometry. Tetrahedra. Abi, the geometry will be what? Tetrahedra. So our what? Geometry here, you can see that what? The lone pair is not equal to 0. So here, geometry is not equal to the shape. What is geometry is what? Tetrahedra. What is what? The shape. The shape here, the angle, sorry, the angle for tetrahedra is what? Is 109 point what? Point 5. Abi? So, uh, sorry, the shape here, we don't know it until what? The shape is also what? Bent. Yes, the shape is also what? Bent or what? It's bent. Or you can call it what? V shape. The shape is what? Is bent. Shape and angle. A it will what? Is one for under normal this thing. No, the angle is A. This one you don't know the shape because the shape is tetrahedral is bent. The angle here is what? 10 what? 109.5. Let us look at the shape here by draw the structure. Let's draw the structure. A, we have A, we add with what? 3B. We add with what? 3B. So this is A. We have the first B. This is second what? B. This is third what? B. And here we have lone pair. For this kind of structure, don't forget lone pair, bond pair. So between the what? This lone pair, bond pair, we have repulsive force. We also have another repulsive force. This lone pair we have here, hello, it will what? It will repel, will bend. This what? This two bond here. If it's bend the two what? The two bond here. This will be the what? The new bond formation. This will be the what? The new bond formation. So if you bend this, it will repel them. Then the angle at this side now, it will now remain what? The angle at what? At this side, if tetrahedral is what? Is 109. The angle at this side, it will now what? Reduce to what? To 107. The angle is what? It will be 10 what? Angle is 107. Shape is what? Bent shape. So you can see that if these are not equal, therefore geometry and shape are what? Are not the same. Let us look at this in a real molecule. Let me use ammonia as a case of study. Ammonia is N what? So if you want to draw ammonia now, this is your new bond. It will form like this. It will form like this. It will form like this. Then we have lone pair here. That's why we always what? Draw ammonia structure in this form. Because this is supposed to be. But this the one is what will be what? Acted on what? On them. This lone pair is the one that is what? Act or what on them. It will repel them. And the angle here now, it will what? 107. Less than what? Tetrahedra. And if you now do the analysis here, what is what? Bond pair here is 3, lone pair is 1. So geometry is not equal to the shape. Geometric is what? Tetrahedra. But out of the what? The shape is what? Is bent. Shape or the angle bent. Abi, what is angle? A is 107. Less than original what? Tetrahedra. So the last one or the next one, let me call it the last. We can look at what? A molecule of AB 2, E2. So example of this molecule we have what? Water. So here, what is what? The bond pair here. What is the bond pair? The bond pair here is what? Is 2. Lone pair E is what? 2. All together, how many electron pair? Electron pair is sum of these two, 4. That is, you can have what? A, E, 4. Abi, if it's AU4, what will be the what? The geometry. Geometry is not equal to the what? Shape. Geometry is also what? Tetra what? Tetrahedra. And the shape is angle what? Angular. And angle is what? 105. You can see that for this tetrahedra, what is the original angle? 109. But ammonia that have 1 pair reduced to what? 107. Let us look at what this one. That we have how many lone pair? Yeah, A. We have A, 2 bond of B. We have 2 lone pair, 2 lone pair. So this is lone pair, this is what lone pair. Abi? So this lone pair what? This lone pair we have here, we repel each other here. We also repel this. We also want to repel this. Abi? So here now, you can see that just one lone pair bend these two what? Bond. That's why you reduce 2 to what? 107. But here now, how many force bend the what? The bond is what? 2. So when the 2 is bended, this new bond will reduce to form like this. This one will also reduce to form like this. So here now, you now have what? A new angle in between them, which is what? 105. You cannot see that what? The bond angle is the one that we use to what? The bond pair that we use to determine the what? The shape. But we use what? Bond pair and lone pair to determine the what? The geometry. So it will not bend this like this. We will not have this. The same thing applicable to what? To water. Yeah. Example is what? Water. If we look at water, H2O, H, lone pair here. So the lone pair we have now, they are the one that is what? They will repel this. It also repel this. When it repel it, the angle reduced to what? To 105. You may ask, there's part that ammonia, no, you may add that what? There's part that, look at the question in this form. There's part that CH4, comma, NH3, and H2O have the same geometry, which is what? Tetrahedra. Explain the variation in their what? In their angle. You know, the angle of this one is what? 109.9. Angle of ammonia is what? 107. Angle of water is what? 105. What cause the reduction in angle? Due to the what? This one have what? One lone pair of electron that repel the bond pair to reduce the angle to 107. This one have what? 2 lone pair of electron to repel the what? The angle to what? To 107, 105. So we have what? Bond what? Bond pair equal to the what? 3 is equal to the 2. We have lone pair equal to the 1. This equal to the what? X. Then geometric is what? Tetra what? Tetrahedra. And shape is what? Angular. And angle is 105. So please, you can help me to what? to try for a molecule. You can help me to what? To try for a molecule of AB4E and AB3E2. If you add this together, it will give you 5. Automatically, the shape of this, the geometry for this one, it will be what? For the 5, it will be triagonal by pyramid. Abi? So what will be the what? The shape. The shape, we call it what? Seesaw. And this one, the shape for this one, we call it what? T shape. So go and try that one. That is all about what? Valency shell electron pair repulsion theory that we use to what? To predict the geometry and the shape. Where geometry can be determined by what? Lone pair and bond pair, but shape can be determined by what? By lone pair alone.